and I'm SD1 at Nagaro right now, and I'm 3-star on Leetcode, and I'm 3-star on WordShape, and today we are going to solve the questions of POD Leetcode, say number 9 questions. Okay, so this question is your combination sum questions. Okay, this question is combination sum 4, combination sum 4. Okay, actually this is the patterns of combinations 1 and 2 and 3. Okay, today this combination 4 of Leetcode POD questions. Okay, so 9 numbers, and we will understand the idea and approach, that how we'll approach these questions. Okay, and at the last we will discuss about the time complexity and space complexity, right? Leetcode. So Leetcode questions, this question would be asked in Facebook, Amazon, Google and Microsoft's. Okay, and also in the FANG company I can call it. Okay, so we will see that this question could be solved using dynamic programming, yes or not, yeah, greedy algorithm, yes or not. Okay, so after solving the question, after overviewing the question, we will understand that like it could be solved using dynamic programming, yes or not. Okay, so now let's move on the question part, right? So here is the question statements and question problem statements. Now we can see the questions statements here, right? So this is the combination sums 4. Okay, I already said that this is the pattern. This is the pattern questions. You can call it 1 and 2 and 3, means combination sum 1 and 2 and 3. So all the combination sum question link will be provided in the description. So go there and check it out, right? Also, so and now read the question statement. So it is said that given an array distinct integers, right? So what do you mean by distinct integer? Distinct integer means that suppose you are having the array, okay, like 2, 3 and 4, means no any repeated element will be allowed. Basically I can call repeated element duplicate array like 2, 3 and 2. Here we can see that 2 times 2 is appear here and here. So this is duplicate array, not unique array, right? But here is the distinct integers in nums, that is called unique array, right? And target in we have been also given target and return the number of possible combinations that add up to target. We have to return all the possible combination whose element sum up to target. Okay, and the test case guaranteed that answer can fit in 32-bit integer, means it will not exceed of that, right? So we don't have to modulo divide by modulo, right? Basically this is one, it's calling like. Okay, now let's write on the example first of all. Okay, first example. So we are given 1 and 2 and 3. We can see that in that array there is a unique element only. Okay, there is no any repeated element here, right? And also we are given a target, that is 4. So we have to return all the possible combination whose sum is up to target. So okay, or here element is allowed to use as many as possible. Now suppose we are given a target 4, we have to make target means 4, right? So we can use 1 4 times, 1 and 1 and 1 and 1. Now this is the first possible combinations, right? So this is the first one combination, right? Now we can use 1 2 times and 2 1 times. So this is also the possible combination, right? 2. And now we can use 1 and 2 1, right? This is also possible combination. So means basically we can see that ordering can be different, and that will also the possible combinations. Okay, suppose like our target is 4, right? And here we can use 1 times, 2 1 times, and 1 times. So 1 plus 2 plus 1 3 and 3 plus 1 4. This is also the possible combinations. I can use also 1 and 3 1 times. Okay, this is also the possible combinations, right? And also I can use these ones and these ones. Okay, so you can see that total here we can make the possible combination, that will be our several possible combinations. You can also write on that and you can observe it here. 1 2 3 4 5 6. And also what is the one possible combination that we can make? So we can make 3 1, like this is also the possible combinations, right? So we can totally make the total 7 combination here. Okay, so now also write on the one test case, that will be help to know you more about this question, that what this question means. Okay, so now you can see that here 3 1s and 1 3, means the order can be different. Like suppose your target is 4, right? Your target is 4 and you are having the element that is 1 2 and 3. So you can observe here that 1 plus 3 is also 4, right? And 3 plus 1 is also 4. So those possible combination, this ordering is possible in combination of. Okay, you can also note the different sequence, different sequence are counted as a different combination. That this ones means 1 3 and 3 ones, right? This is means, right? So this is total combinations of example 1 is 7s, right? Now let's understand one important thing, that suppose your target is 3, but your element, the array which you are having right now, the element is 9, okay? So there is no any possible to make target, right? Because 9 is already greater than 3, so 3 cannot be made by 9. So that in that way you have to just simply return the 0. Means what does it mean? That if you are not able to make the target, then you simply return 0, and that's it, right? Yeah, so here you can see that constraint which are given, that the length of the nums can go up to 200 and the element go up to the 1000s, and one important point that already said distinct integer, means all element are unique, means arrays, all elements are unique, means array is already unique, means that there will be no any repeated element in the array, okay? Okay, fine. So yeah, so we will solving this question using recursion. Recursions, okay? Why recursion? Because recursion help us to solve this question very easily. Now let's use recursion. So suppose we are given 1, 2 and 3 and target is 4, right? Or now the point is that already we have been told that if you are not able to make target, then simply return 0, right? Fine. So how can we solve this question? And only it said that we can use one element as many times as you want, right? So here we will be using recursion simply. What we will be using? Recursions, right? Recursions. Now why recursion? Because recursion help us to find the combination of all possibilities, and also it whenever you see in question all the possible combinations, then try to find out the approach of recursion, because in that way only recursion can help you in the better approach and the better result. So try to find out the approach of recursion, and because whenever all the possible combinations, okay, all the possible combinations in any question, okay, all the possible possibilities and the possible way and the possible combinations, then try to use recursion in that, because only the recursion that help you to find your answer of that questions, right? Yeah, so here you can see we are here, don't look at the memorization part and tabulation part, okay? Simply understand the recursion. So right now you have to skip these two, these two lines, these ones, and you have to skip these ones, right? Okay, these ones, just skip it as of now, okay? You don't have to look on that. So this is your base case, okay? This is your base case, okay? Base case of the simple recursions, okay? And this is the main idea, which we are here, main idea, okay? We are implementing here, or counting our possible combinations. So why we are doing it like this? Okay, now let's understand. So we are given array like 1, 2 and 3, and our target is 4. So here your k is 4, here your k is target, okay? Here your k is target, k is your 4, right? Fine. Now this is your array and this is your n is the length of the array. We are just passing in the function helper function, okay? In recursion we are just passing the helper function n and nums and target simply, right, from the main method, okay? Now we can understand this is the base case and this is the base case. Now let's understand the question part. In basically you have to look at these lines, okay? What does it mean? That let's understand. We are having array 1, 2 and 3, right? So when you can make the target, when the element should be lesser than the target. So here we are checking, means the k, our k here, I can replace k with the t here, but let's leave it as k as of now. So k is your target, understand this ones, okay? So your k should be greater than the every element which are present in the element, then you are able to make the target of the using your element array element. Now fine, let's understand one thing. This is the answer counting. We will counting our answer here, okay? So now what we are doing, we are iterate the loop, because we have to traverse the array, because we have to use each element 1, 2 and 3, and we can use one element as many as we want to make our answer, right? Now fine. So whenever we are going to use your elements, so this is your index, right? This is your index. What is your index? So we are traversing the loop here, I is equal to 0 and n is the length of the array, and I plus plus and including the I, right? So whenever you are going to pick the element, you have to check every time, you have to check this ones, okay? Means your k should be greater than the current element. Now fine, if the k is greater than the current element, so now let's understand. Your k is 4 here right now, and 1 is and your array of I is 1, so 4 greater than 1, this is possible. Now we go inside the if conditions. Now here what we are doing, we are just subtracting the element from the k, because already we are trying to make the k. Suppose what we are doing here is our k, right? that is your 4, and you are using an element, a element is 1. So when you are going to try to make the 4, you have to subtract this one from the k, right? What we are doing, k minus element, we are simply do that. So we are just simply doing it, right? Okay, skip the dp part, right? As of now, we will understand it later on. Okay, and now what we are doing, whenever, and we are just counting our answer, and when we means that we are just increment our answer plus this ones, right? 1, because we have to, every time we have to increment our 1. Why it is 1? I will make you understand why it is 1. So suppose like suppose whenever you are returning ones in this functions helper, okay, when your k is exactly get 0, basically when your 0 means we are able to make your k. Suppose why 0, why k returning 0? Because you are subtracting your element which you are able to make the k, right? So right now you are subtracting 1, that will 3, right? Now you go ahead, now you will go ahead when calling the function. Now you will, like, suppose understand subtracting 1 means 3 means also 2, subtracting 1 basically it's 1. Now subtracting 1 minus 1, that is 0, means you are able to make the one possible combination, that is your 1, 1, 1, 1. Then if k hits 0, it means you are able to make k, then returning simply 1, then returning simply 1. And if your k gets 0 means basically k gets 0 means basically when your target means k is like suppose 3 and element of the array is 9, so base you are not able to make your k, means when you are subtracting 3 minus 9, it will get minus 6, means your k gets negative. In that way you are not able to make your k, then returning simply 0, okay, that's fine here, simple. So recursion is very simple, and at the last what you are doing, just returning the simple answer and it will get your answer. So this is your recursion part as of now, right? And yes, so we have understood the recursion that we can able to make able to use recursion in that code. Now already I told you, we will see that we can be able to use dynamic programming, yes or no. So now yeah, we can see that here is the some overlapping problem, then we can use here dynamic programming, that's fine. So we already have told. So now we are going to use the dynamic programming, and basically dynamic programming, what is dynamic programming? So I will give you the brief introductions about it in the short term. Dynamic programming, that it just helps us to overcome the overlapping sub problems, and dynamic problem has the three parts, like one is your memoization, tabulation, and space optimization. So first we are going to see the memoization part. Okay, what does it mean? Memoization is basically memoization. What is that? Memoization, we are just storing our pre-computed value in data structures and we are just using it. We will understand the code part. Okay, let's move there now. Yeah, so here you can see that now this is your we are just passing a function here, helper memoization. So now you can, here also I'm passing a dp array here, and here I'm implementing the dp base. Okay, now basically what we are doing, we are just passing an array of target sum, like suppose right now your target is 4. Okay, we are just passing plus 1, so plus 1, this is your 4 size array, so 0, 1, 2 and 3 and 5 and 4. Okay, this is the 5 size of array, right? Now what we are doing, initially in every box there is a -1, -1, -1, -1. Okay, suppose it's just helping us to overcome the overlapping problems. Here we are just storing, when suppose right now already we have calculated a function value and we are going to calculate once again. Why we will waste time on that? Okay, suppose right now your function is f2 already is 2, right? But once again you are going to calculate 2, so you are wasting your time now, because you already calculated the value of f2 is 2. So we have to save the time on that. That's why we are using this dp array, and we are storing the pre-compute value, and then we are just using in that the line number 7, returning the dp of k, right? Now fine. And now after that we are just storing our answer in the dp array k, and the last we are just returning the dp k. This is your memoization part. Simple. This is dp is not that much hard, as you understand that if you just basic and approach an idea of the dp, that's fine here, right? And also we are going to use the tabulation here, so you can see here there is a tabulation approach. I will not going to explain that, because you have to make yourself understand of this code using tabulation approach. It's a very simple approach. You have to just go through this code, okay, and we will get understand. Now fine, I will just make you understand that what is recursion, how we can use recursion in this code, and your memoization. And one hint I would like to give and a tip, that whenever you have been told you have to find all the possible combination, possible path, possible possibility and all that, then try to use recursion in that way and think in terms of index. That will help you to get your output of your any code. Okay, Now let's understand the time complexity and the space complexity of this code, okay, because here we are using recursion and dynamic programming, that is your D. Okay, so now this is your time complexity, this is your time complexity and space complexity. So you can see here that what we were doing there, we were just, you know, understand that I told you that we are using here loop, okay, loop I is equal to I to n, right, and in that way we are passing the if condition, that is your k array of I, and in that way we are calling a function, right, this one. So basically I can calculate that the time complexity Tc would be go up to n into k, basically I can say that it will go up to n squared, right, because if the size of the k on n is similar, then it will go up to n squared, okay. So this is your time complexity, and here a space complexity is big O of n, because we are storing the value, and in stack because we are calling the function that will storing the this ones, and in table so this one, and in your memoization, your time complexity will almost go big O of n, and space complexity will go big O of n plus big O of n. That's fine. So this is your time complexity I discussed, and also I have discussed the problem part and all that. And for your more clarification, I would like to bring you on the Leetcode ID and write on the code, and I will make you show that a test case will passing this code, yes or not. Let's move there on the Leetcode now. And now let's run this code. Here I have implemented you can see here memoizations and tabulations. So let's run this code and let's see the time complexity difference, that it will give the time complexity difference, yes or not. Now fine, because it's very important to understand the time complexity, right? Yeah, now so let's run this code and let's see it will pass all the test cases, yes or not. Now fine, yeah, so let's run this code, and it's go to TLE, right? No, TLE is simple. So you can see here this by mistake here console is just coming. Now let me erase it, okay, now just let me erase it. Now just run it once again. Now let's see it will passing all the test cases, yes or not. Okay, so now we can see that it got accepted on it passing all the test cases. Now let's submit this code and let's understand that it will got accepted or not. If it got accepted, then we will see the time complexity, and this is the memoization part. Okay, now you can see that here it will taking 0 millisecond, because here I am using a tabulation approach and also memoization approach. So you can see simply that 0 millisecond is very huge and most important time complexity that you can find here. So not only I have discussed over the time complexity and space complexity and also the code approach. So thank you so much guys to watching this video till then, and please if you found this video helpful for yourself, then please like on this video and do comment your queries which you are having right now, and please subscribe this channels. It gives us motivations, and thank you so much guys once again. Till then keep exploring yourself, and bye bye.